Howdy, it's Miss Kosh. This proof is for my IB higher level kids. My pre-cal kids might enjoy watching it, but it's really beyond the scope of what AP pre-cal is going to ask you for. So they've told us here in this proof what happens. We want to prove that the product of cosine of theta times cosine of 2 theta times cosine of 4 theta times cosine of 8 theta times cosine of 16 theta, etc., until the last term being cosine of 2 to the n minus 1 theta is equal to sine of 2 to the n theta over 2 to the n sine theta. Okay, so this is a proof by induction, and hopefully you already know what that means, but basically step one, you have to show that you can get your foot on the ladder, remember? So we have to show this is true for n equals 1. So when I plug in 1 right here, I have 2 to the 0 power, which is just 1. So that's just this first term here. Okay, so cosine of theta is equal to, and so this would be equal to what we get when we plug in 1. This becomes sine of 2 theta over 2 sine theta. Okay, so this is basically an identity. This right here is within the scope of things my pre-cal kids can do and my SL kids. But the whole proof overall would just be my HL kids. Okay, so sine of 2 theta we know to be 2 sine theta cosine theta. And this is being divided by 2 sine of theta. And sure enough, we have here the 2's cancel, the sines cancel, and then we are left with cosine theta is equal to cosine theta. Okay, step 2 then says, well, we assume that n equals k. So if we use our ladder analogy, we proved that we can step on the ladder. We got to the first step. Now we're assuming that we're on some random step. Okay, so we can say cosine of theta, I'm going to skip some of these, times cosine of 2 to the n minus 1 theta is equal, oh no, I should change it to a k, is equal to sine of 2 to the k theta over 2 to the k sine theta. So that's what we're assuming. Sometimes it's helpful also to, this is scratch work, and I don't really have a good spot for it, to write out our goal. This is not part of the proof, which is why I'm doing it in a color you might not be able to see. I apologize. But our goal is to get to k plus 1. So we'll say this is sine of 2 to the k plus 1th power times theta all over 2 to the k plus 1 times sine of theta. Okay, so the purple so far is the actual proof. That is just a scratch work, and that's kind of to show us the goal because, oh, I forgot to write down that was step 2. Okay, step 3 is we have to, so we are showing this, we're assuming this, and now we're proving n equals k plus 1. Okay, so we'll have to say, well, this is cosine of theta times cosine of 2 theta times ... I'm too lazy to write all of them out. When I plug in k plus 1 back here, I get k plus 1 minus 1 is 2 to the k power. We get cosine of 2 to the k times theta, and this will equal, well, okay, so keep in mind this last term was here. This is in this previous stretch, let me try that again. Here we have a whole bunch of terms multiplied together. Back here we had one less term. So the last term in this series is where 2 is raised to the k minus 1. Well, now we've multiplied this whole stretch of numbers by one more value, and that's cosine of 2 to the k theta. So what that would equal is this sine of 2 to the k theta over 2 to the k sine of theta times this last term, cosine of 2 to the k theta. Because does that make sense? Hopefully it does. This is a whole bunch of terms, which is all of these, but then we multiplied by this last one, which we can do that if we multiply by multiply by that value on both sides. Whew, okay, here we go. So now this would be equal to, you could write it this way, sine of the 2 to the k theta times cosine of 2 to the k theta all over 2 to the k sine theta. Well, our goal is to get this k plus 1. Well, so here's what I see. I could do a, sorry, I need a piece of scratch paper. I could do a quick little u substitution. I could say let u, not me, but u equal 2 to the k theta. And when I do, this has become sine of u cosine of u. And if you remember, sine of sine of 2u would be equal to 2 sine u cosine u. So when I look at this problem right here, what I see is sine of something times cosine of the same something, and I'm hoping that I could get this to become a double angle identity. So what I'll do is I'll come along and say, well, I can always multiply by a funky form of 1, and in particular, I want to multiply by 2 over 2. Okay, so it's 2 sine of 2 to the k theta cosine of 2 to the k theta, let's extend that, over 2 times 2 to the k sine theta was in my denominator. So I multiplied by a funky form of 1, and now this is 2 sine of u, cosine u, which would give me sine of 2 times 2 to the k theta all over, well, this is 2 to the k plus 1. There's 1 here, we add our exponents, sine theta. This, 2 times 2 to the k is equal to sine of 2 to the k plus 1 theta over 2 to the k plus 1 sine theta, which, you'll notice, was my goal. Happy day, they match. Okay, so therefore we should conclude, therefore, you can't see what I'm doing, therefore we conclude that cosine theta times ... cosine of 2 to the n minus 1 theta would be equal to sine of 2 to the n theta over 2 to the n sine theta. I think that's a pretty fun little proof. Isn't it great? It takes us a page to do it. I hope you enjoyed that. Let me know how I can be of assistance. And subscribe, watch my videos, all those fun things. Goodbye.